Hey YouTube, welcome back. Problem number 204, count primes. So the goal in this one, given an integer n, we need to return the number of prime numbers strictly less than n. So what is a prime number? A prime number is a number greater than 1 and that has no diverse other than 1 and itself. That's it. There is multiple approaches to the problem, but I guess the most efficient one, it will be like the sieve of Eratosthenes. I don't know if I'm pronouncing it right. Let's make sure that if I'm pronouncing it right.
Sieve of Eratosthenes.
Sieve of Eratosthenes. Okay, I did pronounce it wrong. So yeah, let's go back here. So it's a sieve of Eratosthenes. So if you want to understand how does this algorithm work, it will work on 4 steps. So let's just try to describe the 4 steps, and after that we will go directly to the code. So number 1, we will create a prime array. We call it is prime. And this array will have the size of n. And it will be initialized to true. We'll basically assume all numbers are prime in the beginning. After that, we will mark 0 and 1, which is not prime. Okay, and after that, because yeah, they are not prime numbers. After that, we will start iterating from number 2. And we will do something like that. Like if the number is prime, we will mark all multipliers. Mark all multipliers. We will mark all multipliers as not prime, like I multiplied by I multiplied by I plus 1, I multiplied by I plus 2, etc. And after that, we count the remaining true. We count the remaining true values in the is prime array, and that's it. So how this will work? First, let's start here by. Okay, I will handle an edge case since 0 and 1 are not prime. So we will expect n to have value bigger than 2. So if n less than 2, that means we're only searching for 0 and 2, so we return false. Okay, and that's it. First, after that, we create lit is prime, and we said that it will be an array. This array, new array, and it will have n values. Its length, it will be to n, whatever n is, and we will assume everything is true, so we put true. After that, we will make is prime 0 and 1 false, because number 0 and number 1 are not prime. So is prime of 0 equals false, and is prime of 1 equals false as well. And after that, I will make a for loop. So let I equals 2, starting from 2, and we have here I multiplied by I. It should be less than n, and n not I plus plus, I plus plus. Okay, some of you ask why we did that. Why I multiplied by I equals n? A short answer: because all non-prime number less than n will have a factor bigger than, or a factor less than or equal to the square root of n. So we only need to mark multiples numbers starting from I multiplied by I, and we only need to loop I up to square root of n. So basically, we only need to go up to the square root of n when marking the multiple primes. Like when we mark it, like first if a number k has no factors less than or equal to the square root of n, then k is prime. For example, if we have like 49, which equals 7 multiplied by 7. Okay, if we already checked up to 7, we could have already marked all compensates which are less than or equal to 49. That's it. So we only need to check numbers up to the square root of n, because all multiplies below that will have already been handled by similar prime. Okay, so why we start making it I multiplied by I? First, we start from 2 and like multiplies like 2 multiplied by I or 3 multiplied by I will have already been marked by smaller primes. This is what we think we are looking for. So for example, let's say that I equals 5. So when I equals 5, we have here like I already marked down when I equals 2. So 2 multiplied by 5, it will be 10. 3 multiplied by 5, it will equals 15, which is already marked when I equals 3. So we have at 5 multiplied by 5, which is 25. This avoids repeating work and improve performance. So this is why we do multiply by I. Okay, a create is here. I would say if is prime of I. If it's true, basically, we will do what we talked about. We for every number I starting from 2 is prime, we will mark all multipliers as not prime. So how we'll do that? We will create a for loop. Let j equals I and j equals I multiplied by I, and j less than n, and j plus equal I. And here we will say is prime of j equals false. Okay, I guess this one will make it even more weird. It's not that easy to understand why we did that. Okay, let's try to look at this one. In this code, we need to break down this important line from the sieve of Eratosthenes algorithm. So this loops marks all multiples of the current prime number I as non-prime if the is prime array in the is prime array. So why we start by I multiplied by I? Why j is not equal to I? So because all smaller multiples of I, like 2 of I, 3 of I, 2 multiplied by I, 3 multiplied by I, etc., were already marked by smaller primes. So if you want to do like an example to walk through this one, let's say that I equals 5. Okay, let's assume that I equals 5. I equals 5. If I equals 5, the multiplies of 5 are 5 multiplied by 2, which is equals 10, 5 multiplied by 3, which equals 15, 5 multiplied by 4, which equals 20. And already these all numbers already been marked, like for example 5 multiplied by 2, which will equals 10. It's already been marked by I when I was equal to I, and 5 multiplies by 3, for example, which equals 15. It's already been marked when I was 3. and we have 5 multiplied by 4, which equals 20, already been marked by I equals 2 or I equals 4. So we start at 5 multiplied by 5 because that's the first multiple of 5 we haven't marked yet. So because of that, we start I multiplied by I. So yeah, because of that. So again, if we want to try to understand it, because all the smaller multiples of I, like 2 multiplied by I or 3 multiplied by I, if you assume the I is 5, we already marked them by the smaller primes. So because of that, we do I multiplied by I. So here, if you want to understand this, if you have I, j equals I multiplied by I, here we start from the square of the current prime, I less than n. So again, we stop when j reaches or exceeds n, and I plus or equals j plus equals I. We here increment j by I, like move to the next multiple of I. If you want to do an example walking through, so let's say that n equals, sorry, I'm describing a lot for this problem, but I guess it's really worth it. N equals 20 and I equals 3, for example. So here we mark down is prime 9 to false because j is we start marking from j 3 multiplied by 3, and we have 9. So when we start by 9, so j will equals 9 because j it equals I multiplied by I, so j will equals 9 because I equals 3. So here we mark is prime of the index 9 to false. Then j will equals I guess j will equals that 12. Yeah, because plus equals I. So, and j will equals 15, j will equals 18. We mark all these as false, and we stopped when j equals 21 because we will stop when when j is bigger than n. So yeah, because of that, we did all of this. I hope this explanation was quite good for you guys. Okay, so by doing this, I guess we have only one last thing to do, or what? Yeah, we only have one thing to do, which is to return is prime dot filter, and I have here a boolean and dot length. Yeah, I just returned the length of all true. Let's run and see if it works. It didn't work at all. Why? We return is prime length is not defined. The length is not a method, sorry. Okay, again, we throw an error. False. Return is prime dot filter, and why didn't it work? I guess it should work. False is not a value for unexpected. I'm not returning false. I'm returning the number. Can I see here a const result equals, and I should return result. Let's say that like that. And let's debug the code and see. Here, okay, so I have result equals 4. Okay, it should work. Result is 4. Stop, run. What? Okay, this is weird. I'm returning. I'm returning the number, dude. Okay, okay. I will just try to copy the solution that I have done before, and let's see if it work or not. I don't know if it will. Oh shit. Okay, what did I do wrong? What did I do wrong? I don't know what did I do wrong, to be honest, guys. So yeah, just if you know what I did wrong in my first solution, just tell me in the comment section below. So yeah, that's it for this problem, and yeah, see you in future problems.